In this video, we're going to be talking about special angle pair relationships, and later on we'll be doing lots of algebra. So get ready, here we go. First and foremost, for each of the next couple of slides, I want you to just press pause and copy everything that's here, and then I'll talk your way through it. So press pause now and copy what you see into your notes. The first set of angle pair relationships that we're going to be talking about are vertical angles. And vertical angles are two, right? So everything that we're going to talk about today is two angles. These two angles are across from each other, and they generally form a set of, looks like V's sort of bumping into each other. So 3 and 4 would be an example of vertical angles. Also 1 and 2 would be another example of vertical angles. Most importantly, they are always congruent. So whatever 3 is, 4 is. Whatever 1 is, 2 is the same thing. So over here we have the notation. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Vertical angles, always congruent. Next. Press pause and get adjacent angles into your notes. Okay, so adjacent angles are two angles, again, two angles that are next to each other and share a common side. They also share a common vertex. So here's their common side right here. Angles 1 and 2 are adjacent. Now there's nothing special about what they add up to or anything like that. It's just what they are as far as where they're located. They are located next to each other and they share a common side. All right, onward and upward. Press pause now and get complementary angles into your notes. All right. What are complementary angles? Is it one angle that says to another angle, hey, I love your haircut today? No, that's not the complementary that we're talking about. Complementary angles are two angles, you get tired of this two-angle business yet? Whose sum, what does that mean? When I see the word sum, I think addition, right? Two angles who add up to 90 degrees. So in this picture, I see the box, and you know from right triangles that that box means 90 degrees. Then angle 1 plus angle 2 must add up to be 90 degrees. Okay, next. Obviously, press pause. Get this into your notes. Supplementary, very similar to complementary in the fact that it's two angles who have a sum, but the supplement is 180. So you got C on complementary is 90, and S on supplementary is 180. So it's kind of a crummy 90 and 180, but C is before S in the alphabet, 90 is before 180 numerically. So that's how I keep those squared away. S goes with the 180, and the C in complementary goes with the 90 degrees. Okay, so now we see two angles here whose sum is 180 degrees. If you take 135 and you add it to 45, you're going to get 180. So yes, these must be supplementary. Now, these happen to be together. They don't always have to be next to each other. Complementary and supplementary could just be separate, two different angles. But when I do have supplementary angles, I have our next vocabulary word. Two supplementary angles who share a common side. Let's take a look. Go ahead and press pause. Get linear pair into your notes. Okay. So linear pairs, again, P-A-I-R, insinuating that we have two angles again, right? They are adjacent, as we know from the word adjacent. Adjacent means next to. So we have two angles that are next to each other. They share a common side, so here's that common side. And they are supplementary, and as we know, that means that they add up to be 180 degrees. Linear pairs always form a straight line, hence the word line in the name. If you mispronounce it, it's a linear pair. And so what do I know if they're supplementary? That angle 1 plus angle 2 adds up to be 180 degrees. And this will be useful in solving problems in a few seconds. Now we're going to put all this vocabulary into action. So I'm looking at number 1 here, and it says basically check off all the boxes that apply. So I'm looking at angle 1 up here and angle 2 down there, and it looks like that two V's bumping into each other again, and I believe that was our vertical. Now they're not adjacent. They are next to each other, but they don't share a common side. There's space between them, so they're not adjacent. And I don't know what they add up to, so I can't say really for sure if they're complementary or if they're supplementary. And they don't form a straight line, so they're not a linear pair. They're simply just vertical. Over on number 2, I see this 90-degree box and I see this straight line. So when I have a straight line like this, if this is 90, then this other side must be 90 as well. So I'm going to put a blue box on this side. Well, I have two angles that are next to each other and they share this common side. So 1 and 2 are at least adjacent. They're not verticals. They don't form two V's. Right? And if I'm checking off adjacent, they can't be vertical. If I'm checking off vertical, they can't be adjacent. I know that 1 and 2 add up to this blue box, right? They're 90 degrees, so they're certainly complementary. If they're complementary, they add up to 90, can't be supplementary. And if they're not supplementary, well, they certainly can't be a linear pair. As you'll notice, you need to complete 3 and 4 on your own. I'll walk you through 5 and 6. So now the picture is getting a little bit more complicated, so I'm going to just kind of copy part of what's going on above us in number 5. It's been given that this is 90 degrees, and so by vertical angle argument, that is also 90 degrees. And since this is a straight line, this is going to be 90 degrees, and by vertical argument, that is also 90 degrees. Or just the fact that this is a straight line, these two angles must be adding up to 180, and 180 minus 90 is 90. So all of these angles up here, this is 90, and this is 90, and that's 90. And then if you look, those little arcs, right, you got these arcs and angles going like this, and you see boom, boom, that means that those angles are identical. So whatever one is, this little angle in here is also the same thing. Anyway, moving on. I want to identify what kind of angles 1 and 2 are. Well, I think 1 is 45 degrees because this angle got split in half. So if 2 and 1 are the same, well, are they vertical? So I just want to trace this. Vertical angles are always going to form an X, and it looks like 1 and 2 do form an X, so I think they're vertical. They're not next to each other, so they're not adjacent. Angle 1 is 45 degrees, which makes 2 the same thing, because remember, if they're vertical angles, right? Vertical angles are congruent. So, sorry, my pen doesn't seem to be working very good on the screen here tonight. Vertical angles are always congruent, and so if that's 45, then 2 is also 45. And if they're both 45, that means they add up to 90, so they are complementary. If they're complementary, they can't be supplementary. If they're not supplementary, they can't be a linear pair, because linear pairs are supplementary automatically. So it looks like 1 and 2 are vertical, and they are two angles whose sum is 90, so they are complementary. Over on number 6, it looks like 1 and 2, again, they do form an X, so they are definitely vertical, can't be adjacent if that's the case. And if this angle right here is 90 and this forms a straight line, then by argument, that is also 90 because this whole thing has to be 180. So 90 plus 90 equals 180. It's the only way that's going to happen. And if 2 is 90, then guess what, folks? 1 is as well because they are vertical. Also, this adds up to be 180 because this is a straight line. So for lots of reasons, 1 is 90 and 2 is 90 degrees. So since they're both 90 degrees, if this is 90 and this is 90, 90 and 90 is 180, which makes them supplementary. If they're supplementary, can't be complementary. Now the question is, are they a linear pair? Well, first, to be a linear pair, they must be adjacent, and they're not adjacent, so they can't be a linear pair. And that's that. Try 3 and 4 on your own. Then let's move on. Copy this onto your paper, and I really would recommend that you put it in separate line paper. The steps to solving lots of problems this year is going to involve the following process, right? We're going to be talking about just angle pair relationships today, but this process is really the process for lots of geometry problems coming your way. First, you must identify or define the relationship, right? And I say identify/define, it's one and the same thing. Then, we're going to put a vocabulary word to it. Then we're going to use the definition of that vocabulary word to write sort of a generic statement. We'll substitute in the given information and solve. And all of our problems as we solve them are going to look just like last year's mathematics. So why did you need to learn algebra? To solve geometry problems. And then at the end, make sure that you actually have answered the question that we've asked. Just because you solve for x, if we're asking for the value of x, then yes, you've answered the question. But sometimes we want the value of an angle or the length of a segment. That's the actual question. And we may need x to get that answer. So buckle in. It's going to be a long ride. First, we're just going to attack the basic numerical versions. And what I see here, I see this x degrees and 112 degrees. And the instructions ask me to find the missing measures in each figure and keeping the relationships in mind. So let's keep our problem-solving process in mind. First, let's define the relationship between x and 112. These angles have a vertical relationship, and vertical angles are always congruent. So I want to write a generic statement. What does that mean? Well, if they're congruent, then I can write the following. Generically speaking, if two things are congruent, I can set the terms equal, right? So the idea that I have this congruent relationship algebraically means I can set things equal to each other. So I have x on the one side, and then I have 112 on the other side, degrees. Now, since there really isn't anything else to do, I'm done. X is equal to 112 degrees. Onward to number 2. What do I see here? The first thing I see is this right angle. So I know that that whole thing is 90 degrees, and I have two angles here. So when I see that right angle and I have two angles, they happen to be adjacent, doesn't have to be, but I think that these are complementary. So what does that mean algebraically? Algebraically, if they're complementary, it means that they add up to 90 degrees. So I have the measure of angle A plus the measure of angle B is equal to 90 degrees. Okay? And now I'm going to substitute and solve. So I have this definition piece here, and then I'm going to substitute. So instead of angle A, I say that's x plus 68 equals 90. Now I have a little bit of algebra to do, so I'm going to subtract 68 from both sides, and I'm left with x equals 22. Now x happens to be the value of the entire angle, so x equals 22 is my final answer. I guess we'll say that x equals 22 degrees in this case. Okay, so very similar to number 2, I'm looking at number 3 and I'm thinking, all right, well I have this straight line and I know that this whole thing is 180 degrees. I have two angles who are adjacent to each other that form a straight line. Oh, these are supplementary. Now we know that supplementary means that the measure of angle A plus the measure of angle B equals 180 degrees. So what have I done as far as that problem-solving process? I've identified the relationship. I've written a generic statement. Now I'm ready to substitute in and solve. So after subtracting 124 from both sides, right, just performing some basic algebra, my x drops down and I'm left with a very sadly written 56 degrees. That's the value of that angle. All right, let's move on to more algebraic versions. So here, what are we given? We're given some information in the get-go here that 1 and 2 are vertical angles, right? And then they tell me that the measure of angle 2 is 105 degrees, and they want me to find angle 1. So I hear the word vertical. And from all of this information, I can now produce this statement. They said vertical. I say, oh, okay, they've already defined it for me. Vertical means, my second step in the problem-solving process, is to write a generic statement. Two angles are equal to each other. Substitute and solve. They told me the two angles. Angle 2 is 105, and find angle 1 means I don't know angle 1. So I set the terms equal, and I guess I'm all done. The final answer then is that x is equal to 105 degrees. Move on to number 7. Number 7, they said A and B are complementary. And if they're complementary, that means they add up to 90. Angle A is 42 degrees. Find angle B. So again, complementary assumes a 90-degree sum. So complementary is the defined relationship. My generic statement is that two angles add up to be 90 degrees if they're complementary. A is 42 degrees in this case. Angle B is unknown, so I'm going to write in x is equal to 90. Subtract 42 from both sides, finish and solve. The measure of angle B is 48 degrees. Right? I say it's x, I called the measure of angle B x for the algebraic version, but the actual value of B is 48 degrees. Now we're really starting to step things up. We have a picture here, and they give us some information at the get-go, which is the measure of angle PQT. So the first thing you really need to do is go find that in the picture. So angle PQT is right here. Remember that the middle letter Q is always going to be the vertex of the angle. So PQT is there. And so the measure of that angle is 3x plus 47. So that goes here. Next, we have angle SQR. Where's SQR? SQR is down here, right? Just trace it, SQR. The value of that angle is 6x minus 25. That goes there. And what kind of angles are these? Well, it looks like they're two V's, right? They form an X. Again, that whole X business, these guys are vertical. And vertical means they're what? Congruent. Keep looking back at that first page, at your vocabulary. The concept of vertical angles and linear pairs and supplementary and complementary are going to be with us all year. We have to remember them all year long. It's not going to be that difficult because we're going to be using them on a regular basis. So here's what we have. We have the defined relationship of being vertical. All right? It wasn't given to us, but I recognize that in the picture. So since they're vertical, I can set the terms equal. So the measure of PQT is equal to the measure of angle SQR. If that's the case, I can substitute and solve. And here's what I mean by substitute. 3x plus 47, where did I get that from? Up here, they said that PQT is equals 3x plus 47. So wherever in the defined relationship I see PQT, I can substitute in 3x plus 47. Think about it as like two defensive players on a soccer team. This was my first string, this was my second string. First string over on SQR is the measure of angle SQR. Second string is 6x minus 25. Wherever I see SQR, 6x minus 25 is just as good. So if these two measures equal each other, then algebraically I set these terms equal to each other. Now comes the tough part, the algebra. Now the first thing I'd like to do is to subtract 3x from the left side. Why did I choose to subtract 3x from the left side? If I subtracted the 6x, which is very much an option, I would have ended up with a negative 3x. And I don't want to bring negatives in there because I have a problem with signs. I don't want to make sign errors. So I'm going to choose to subtract 3x from both sides. And I bring everybody who I didn't touch down. So the 47 drops down. 6x minus 3x is 3x. And negative 25 is still negative 25. Now what? Now we're going to add the 25. So we've added the 25 to both sides. That cancels out our 25 on the right side. And we're left with, I never canceled that out, we're left with 72 equals 3x. I divide by 3 on both sides, divide by 3 on both sides, and I'm going to get a final value of x of 24. Now here's that point where I say, hey, this is certainly the value of x, but that's not answering the question. The question is, what is the measure of SQR? SQR is 6x minus 25. So the measure of angle SQR is 6 times 24 minus 25. So let's go ahead and calculate what that is. Okay, so I've done two things. I've actually gone ahead and calculated the measure of angle SQR, right? I substituted 24 in for x into this measurement of angle SQR, and I got 119 degrees. Now, for all intents and purposes, this is our final answer. But we said at the very beginning right here that these two angles were the same measure. So I went over into PQT and I put 24 in for x there just to see what is 3 times x plus 47 worth. Well, 3 times 24 plus 47 is worth 119. And they're supposed to be the same, and they are, so I put a little check here. That's how I know that this is all right. And I think that you're starting to believe that, yes, this is going to be an algebra-intensive, tough class. Don't worry, as long as you do the work, right? You have to do your part, your responsibility. Follow along with me, ask plenty of questions. We will get through this together. Okay, next question. Promise these get easier as it goes. So it looks like I have a couple of rays here. I got ray AB is perpendicular to CD. So this piece here is perpendicular to here. That's what that little symbol means right there, perpendicular. And it implies that a 90-degree angle has been formed. Now that right angle has actually been formed on both sides. So over here is also a 90-degree angle. And we know that since this is a straight line, that this whole thing is 180 degrees. Okay, so let's clean up this picture now that we have that understanding. I'm just going to leave that right angle there, but remember, it's on both sides technically. So now we need to go find DCE in the picture, and that's right here. That's this angle right here, from D to C to E. I just trace it as I read it. And then there's also angle ECB, right? So where's ECB? Starting at E, going towards C to B. And what do I have? I have two angles that are adjacent, and it looks like they form a right angle. So I think we're talking about complementary angles. Right? And if I'm talking about complementary, I'm talking about the measure of angle A plus the measure of angle B equals 90 degrees. Now let's go ahead, substitute, and solve. We've defined our relationship, right? We got the complementary, and I just write comp. We know that we have a generic statement that the two angles add up to be 90 degrees. Now we're going to substitute in that known information and solve. Here's our algebra statement. We got the 7x plus 2. That was our first angle. And our x plus 8. That's our second angle. And so algebra would require us to combine like terms. So who are our like terms? The 7x here, the positive x here. So I think that gives us an 8x. Then we have a plus 2 here and a plus 8 here. That's going to give us a positive 10 equals 90 still. Then we're going to subtract 10 on both sides and divide by 8. So go ahead and try to finish this out on your own. Press pause and finish this one out. Get a value for x. Did you get a value of x equals 10? Now I didn't show my work, and it's kind of a bad habit, but I was running tight for space here. So I got a value of x equals 10, but that's not the measure of angle DCE. The measure of angle DCE is 7x plus 2. So I need to just substitute the value of 10 in for x to get the actual measure of angle DCE. So let's go ahead and do that. So I've shown my work down here. 7 times 10 plus 2 is 70 plus 2 is 72 degrees. So the measure of angle DCE is 72 degrees. By the way, they should add up to be 90 degrees. If I put 10 in for the measure of ECB, I'm going to get a value of 18 degrees. And 18 plus 72 is 90. So I feel pretty good about this answer. All right, so again, our final answer is 72 degrees, but all of the work is all this on the left. All right, let's move on again. We're down to our last two problems, but again, I can't impress upon you how important it is to follow this process. The more you embrace this process early on in the year, the smoother your year will go for you. All right, so here we have KNM. So where is angle KNM? Again, just trace the letters from K to N to M. That's this angle right here. and that is worth 8x minus 5. M and J is worth 4x minus 19. Where is it? That's from M to N to J. And so what do we have here? It looks like they're adjacent. It looks like they form a straight line. I think that these are a linear pair. And a linear pair means that they are supplementary. Now keep in mind, during this video, you should be writing everything that I'm writing on your notes. So even this piece right here, you want to write linear pair, supplementary, identifying the relationship, and then stating what that means. So that means that the measure of angle A plus, generically, the measure of angle B equals 180 degrees. Now, when I write that generically, I've now defined, had a generic statement. Now I'm going to substitute something that is algebraically solvable. So instead of this K and M, right, I'm going to write 8x minus 5. 8x minus 5 plus my angle B, so to speak, is this other angle over here, 4x minus 19. 4x minus 19 equals 180. Now again, combine like terms, use some algebra 1, solve for x. Pause it, work this through on your own. Don't keep following my work. Right. Did you arrive at a value of x equals 17? So we got a value of x, but we need to find the measure of k and m. So what do? We take 17 and we come over to 8x minus 5 and substitute that in. So after I substituted it in down over here, I have 8 times 17 minus 5 is 131 degrees. So up here is my final answer, 131 degrees. But I also substituted in 17 into the other angle to find its measure, and I take 49 and I add it to 131 to make sure that I do get this 180 degrees. Now, truth be told, while I had this on pause, I had done this incorrectly, got a incorrect value of x due to hasty algebra errors, and when I went to go check my answer, as I just did, I didn't add up to be 180, so I knew that I was wrong. So again, check the whole thing. Don't just answer the question. Go through the process of checking your work. It does make a difference. Now for these last two problems, I'm just going to set them up, and then you're going to finish and solve and bring this in for the rest of your homework. So on number 14, what I see is the word complementary. So you have angles R and S, and they are complementary. Angle R is 12x minus 3. Angle S is 7x minus 2. So if it's complementary, I'm just going to draw down here that means that I add up these two angles and I get 90 degrees, because that is the generic relationship between complementary angles. Over on the right side, number 15, you have P and Q are supplementary. And supplementary means that if I add the two angles up, I get 180. So I don't really need to define them because they were already kind of defined for me. So the defining moment happened, my generic statement happened, the defining moment happened, my generic statement happened. Now I'm just going to substitute in and solve, and I'm going to really just substitute in. I'm going to leave the solving to you. Now just one last mention. I know that they call them R and S and P and Q, and then I wrote A and B, and not to confuse you, but I just tend to generically in my statement just use A and B. I know that I'm talking about generic angles. And so it might be more helpful to think about this as the measure of angle R plus the measure of angle S equals 90. So on and so forth with P and Q. Anyway, here are your algebra statements. You're going to need to get a value of x for the problem on the left and a value of x for the problem on the right. Okay? And once you're done with those, the actual final answer for number 14, pay attention, is find the measure of angle R. And the final answer for number 15 is to find the measure of angle Q. So that requires substituting your final answer back in for Q, and over on this side, substituting your answer back in for angle R to get the final answer. But of course, you know me, I would substitute into both and check your answers to make sure that the sum over here does add up to 90 and the sum over here does add up to 180. Thanks for your time. We'll see you in class.